Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis from Autodesk. I have on the keyboard helping out with chat my friend Angelo Juris. So as we're going through the live stream, if you have any questions, please feel free to throw them in the chat and he will try and get those to me. We use a shared Google Doc that I can take a look at. So if you have any questions as we're going through, please feel free to post them out there. With that said, I hope you are all attending Angelo's CAM live streams. We've basically been doing every other Thursday, and I know, me personally, I've been learning a ton from his CAM live stream. So make sure you've subscribed to the Fusion 360 channel, and make sure you're attending these Thursday live streams. So with that, let's dive right in. I'm actually going to start out by showing a couple new things that were just pushed out in the latest release. Check this out. So we now allow you to scroll through the browser using the arrow keys. So I'm actually hitting my up and down arrows. If I hit to the right, you'll notice it open the leg assembly. If I hit to the right on my arrow keys, so I can scroll up and down, which I think is really pretty cool with that. And then the other thing that we've added that I really like is in the sketch, under modify, you'll now notice a new chamfer command. So not just in 3D, you can also do it in 2D. So for example, equal distance, distance and angle, and to distance. So you'll see, for example, I get near this corner and it's going to create that chamfer for me, whatever size I want that to be. Or if I were to come in and say I want that to be, for example, a distance and angle, you can see we get live preview. I can type in what that angle is and what the distance is, etc. So a little bit of new functionality. There's a lot more, obviously, in like the manufacturer workspace and the electronics workspace, etc. I just wanted to kind of highlight those two before we dive right in. Okay, we left off last time at this position here where we spent the time creating the leg. We created this insert and then the pin. We put the washer and the little clip on there. And then I think the last thing we ended up with was this foot. In fact, I think I probably won't be able to move it. Yeah, it's the whole assembly. Anyways, we designed the foot and we ran out of time to be able to position it in the correct location. So that's what we're going to do today. We're going to create these legs and then we're going to work on the handle. We're using some 3D sketch techniques to create this handle for moving the whole miter saw station. Okay, so what I want to do is we're going to position this leg into the correct location. We're going to learn some tips and tricks with that. But then we're also going to use information from this model to create kind of a locking slot for this pin when it's all folded up. And you're going to see some new techniques with that. So let's start out by, I'm going to activate the leg assembly because I'm still kind of working on that right now. Actually, let's see. No, I already did. We already positioned that, so I don't need to do that. But what I do want to do is if I move this around, you'll notice that some of these parts don't move with it. And I showed the cool little trick where in this whole assembly right here, I can right mouse click and say rigid group. And sometimes it might say you already have some joints or some constraints existing. Do you want to continue? I usually say yes. I'll go ahead and say okay. And now notice when I move that leg that everything moves with it. So I didn't have to build a bunch of different joints. I just said, hey, this whole thing is going to move together. And the really quick way of doing that is just to right mouse click and say rigid group. Okay. What I want to do now is I'm going to activate this table assembly and I'm going to create a joint. Now you're going to see something new with this new release. When I create my joint type, you're going to see a couple new little icons and the little, let me zoom up here so you can kind of see what this looks like. The little glyph and it's a little hard to see because it is pretty tiny, has these little directional arrows. I'm going to hover right there so you can kind of see the blue, the red, and the green, where before it was just kind of that flat coin. Some people called it a coin, some people called it a happy face. Well, now we've added some more detail to kind of show the direction that we're clicking or you're picking. So I want to basically put this hole to line up with this hole here, but this is a curved surface, and you'll notice if I hover over the edge, my little 3D glyph is not really pointing in the right direction. However, I'm going to zoom up just a little bit. If I hover over the face of the hole, you'll notice that it has a start, a middle, and an end point. And this start point is basically on the outside, the tangent of this hole. So I'm going to click that point as my component 1. So I'll click there. And if we kind of rotate, you can see, hopefully you can kind of see, that that is lined up with the tangent of this pipe here. Then I'll come in here and say I want that to be basically touching this surface here, so I'll grab that point. I could also hover over this face and grab that point there. It really doesn't matter in this case. I'm going to zoom out so you can kind of see how this thing's going to move and look. So let's just do that, for example. And you're going to see that the pipe, or the leg, moved into location. And it's tangent with this face right here. And we're going to do that again. You'll see that more often, so don't worry. Now I want to change the motion type to a revolute. And you guys are probably saying, hey, didn't you just do a rigid joint for the whole leg, and so these parts all move together, but now when you go to move this leg, these parts aren't moving? Well, again, that has to do with right here, component 1 and component 2. We're only dealing with 2 components at a time, the leg and the leg support plate. As soon as I say OK, you'll see that everything updates. That rigid joint group has to update. Now if I try and rotate this leg, you'll see some weird things happen. The whole plate moves. I don't want that to move. So I'm going to click on it to find it in my structure browser here, so I can see that it's in the end cap assembly. And I can see, because it's like underlined, that that's the leg support plate. I'll right mouse click on it, and there's a command here called ground. Basically what I'm saying is I want this part to be stationary. I want to ground it in place. So I'm going to hit ground, and now I physically can't move. Even though I'm clicking and dragging, I can't move that part. It's ground in place. And if I were to grab the leg, now we can kind of simulate how this thing would work. So you can see that sure enough it's pivoting around that hole right there that we just lined it up with. Now here's one of the drawbacks. I spent quite a bit of time trying to figure out how could we now line up this pin with this hole, and if I tried to create a joint between, you know, for example, in fact I'll turn off the pin. Let's turn off this lock pin here. If I try and line up this face here, whoops, it's pretty touchy, so I'm going to zoom up, grab that first point there, and then I'm going to line it up with this point here. Yes, I want to go ahead and do that. You'll see it says the joint type will result in a conflict, and you can see that sure enough it's revolving around that, but as soon as I say OK, it fails, right? It doesn't work. And that's because this already has a joint type there. So I had to come up with a different method. We're going to use some 3D geometry to help us figure out what angle this needs to be, because I don't know the angle between those two lines. And if I were to try and measure, if I go maybe like between that circle there and that circle there, it tells me the distance, but it doesn't tell me like the angle or anything like that. If I do my XYZ delta, it does tell me distance, but I want to know how far do I need to rotate. So what I'm going to do is let's just create a sketch. So I'm going to say create sketch on this angled face, and I'm going to project some geometry. So let's project maybe like this hole here. We'll project that hole there, and let's just do that guy there. Okay, so we just projected some geometry. Then I'm going to use the line command and change to a construction line type. I'm just going to draw a line kind of, down here through the center of this guy. And then I'll draw another line from here to that guy. So I'm just using some construction geometry, lining up with the first hole or the pin, and then this hole here. And now if I go to my inspect menu and I say measure, I'll just click on these lines. So I'm going to click on this line here and this line here, and notice it gives me a result. In fact, let me stretch this guy out a little bit, make it a little bit longer. Angelo showed this on his last live stream, and I think it's really important. If you undock one of your dialogues, it allows you to stretch the corner out and all this kind of stuff, but you typically don't want to leave them floating. And so if I move to the right, you'll see this green bar appear, and I can redock it back to like the sketch palette, for example. So kind of a neat little trick. So, okay, so I click those two lines, and this time it does give me an angle. And notice when I hover over the number, it says click to copy to the clipboard. So I'm just going to click on that number, and it captured it into my clipboard. And that's important because it might be only showing like 3 decimal places, but this could be 10.305892 or something like that. And it's just showing, actually, the 3 decimal places, the precision. So I like to copy that because it's going to copy is how many decimal places it actually is, whatever the number is. So I clicked on that. We're good to go. I'll finish my sketch. In fact, I don't even need that sketch anymore. So that's my table assembly. So I'm just going to come over here and turn off that sketch. And then I want to, I think I have my, I have my joints turned off. Notice I don't see a little joint icon where I created that Revolute. And if I come into my object visibility, you can see, oops, it's off the screen a little bit, I apologize. Right there is the joint. So I'm going to turn that on, and sure enough, that shows up. So as you're working in a complex assembly, you might see all these joint icons and you don't want to see them. You can turn them on or off using this object visibility. So now I can see this guy, and I'm going to edit that joint. And notice the angle right here. This is the default. So it's at 0, 0, 0 at the angle of 0. Well, I'm just going to paste my result in there, and we can see that sure enough it rotated the leg. However, it rotated it in the wrong direction. So let's put a minus sign in front of there, and now you can see that it rotated the leg the correct angle for that pin to line up with that hole. So a couple steps to do this, but what's really neat is we're using the actual geometry to figure out that angle by projecting those holes, creating those lines, and using the measure command. We knew it was exactly 10.305. I didn't have to guess and hope that the holes are lined up. We mathematically figured that out. Okay, so I got that where I want. In fact, I'm going to turn the joints back off just to kind of keep things a little bit cleaner since we're doing some stuff here. The next thing I want to do is we need to somehow mount this into place. So we're going to bring in a Mcmaster car component. I'll stretch this out a little bit. And like I showed in the last time, I could hunt for them, by clicking on screws and bolts and, picking the size and all that kind of stuff. Or I can actually just come in and type in the number, and in the outline that I include, I always include the number of the Mcmaster car component. So in this case, it's going to be 98930 alpha 229. And if I hit enter, you'll see that it went through and it found some metric square net carriage bolts, and it actually highlighted the one that, that I did. So this is a metric 10 by 70, you know, et cetera, et cetera. So, and you can see the product number right there. Because there's this little CAD icon, I can click on that and I can specify, I want this maybe as like a step file, for example, and I'll say download. And it's gonna bring in this, you know, M10 by 70 square neck carriage bolt and bring it right into my session. I'm just going to kind of drag it sort of close to where it needs to be. Doesn't need to be exact. And I'll just say OK. And I'll use a joint to put that into the correct location. So I'm going to grab this kind of circle right here, this edge, and you can see that it's grabbing the center point of that edge because I want this face to be flush. So I'm just going to grab that. It's going to find the center of it. It's going to find the plane of that. So that's the component. That's the one I want to move. Where do I want to move it to? I want to move it to this circle right here. And you'll see it rotates it in place and puts it through the sleeve and through the holes and everything like that. Pretty snazzy, pretty quick. Okay. And let me just scroll to the end. If I ever wanted to, I could edit that joint, go to the motion, and it's a Revolute joint. In this case, I'm going to just make it a rigid joint. It doesn't need to revolve in the, you know, I could if I wanted to, but in this case I don't want it to. So I'm just making that a rigid joint. Let's insert another Mcmaster car component, the correct nut for that bolt. Again, I could search for it by hunting through and filtering, or if I know the particular number in this case. And some people I know actually go out to the web page instead of using this dialog inside of Fusion. They just go out to the web page and search for it, and then they just type in this number, for example. So this is going to be a nylon insert lock nut, a metric 10, obviously. I'll download that. It's going to bring it into kind of like 0, 0, 0. And you'll notice it's kind of pointing in a different direction, whatever, but that's okay. I like to click this capture position. That way it doesn't ask me, you know, before I do the next move, do you want to capture the position? If I just say okay, I can now do things and it's not going to ask me that question. So let's say joint. I'll hover over the circular face and grab that center point. That's the component I want to move. Where do I want to move it to? I'm going to move it to the edge of this circle right here. So I'll click there and we'll see that the nut comes into place, and it's going to default to a Revolute, which is fine if you want to kind of simulate that's what it would look like. Or I can make it a rigid. It really doesn't matter in this case. I'll go ahead and say okay, and we now have the bolt and the nut in the correct location. Okay, so what I want to do now is, you know, I'm pretty much done with this leg. It's in the correct location, it's at the correct angle. I want to move it over to the other side. So I'm going to go ahead and mirror this. So let's go to Create, Mirror. And I don't want to mirror faces. I want to make sure I'm mirroring components. And yeah, I'm going to do that. Let's just check in my notes, make sure I'm doing this the way I want to. What are my objects? Okay, so here's where it's going to get interesting. So if I mirror the leg assembly, okay, and I pick my mirror plane, and I know I have a plane that kind of slices right through the middle, like so. That's going to be my mirror plane. I'm going to click on that. I'm going to say OK. You'll notice that the leg mirrored over, but the bolt and the nut did not. Now, why is that? Well, it has to do, in fact, I'm going to undo, so that goes away. has to do with kind of how I organize this stuff. I was having my table assembly be active, and I'm trying to simulate what happens in the real world with all of you guys. I didn't have my leg assembly active when I inserted the bolt and the nut. In fact, you can kind of see they're at the same level as like this end cap assembly, etc. They're not inside this leg assembly. So I could grab these. I'm just going to drag and drop them onto my leg assembly. And you'll notice they kind of shifted over a little bit. They are now underneath this leg assembly. And I can verify that just by kind of like hovering over it. You see how it highlights everything? Okay. If I were to undo, if I hover over my leg assembly, you'll notice that the nut and the bolt are not highlighting right there because they're not inside of it. As soon as I put those inside and I hover over my leg assembly, sure enough, we can see that it highlights all of that. So this is just one of those tips where you can design, you can be inserting things in, bringing in other components, and you realize, oh, they're not in the sub-assembly or the sub-assembly. Well, you can just drag them around and move them into the correct location, and that's what I was showing here. Okay, so now I should be able to do my mirror, and we get a much better result. So I'm going to say mirror, what are my components? I can click on just the leg assembly. What's my mirror plane? This plane here. I'll say OK, and we can see that, sure enough, this time the nut and the bolt came over along with the pin and all that kind of stuff. However, if I were to grab that, you'll notice that it's not grouped together. They're individual, right? So I'm going to right click on this leg assembly and just say rigid group. I'll say OK, and now they are all grouped together. But you'll also notice that there isn't a joint. And I always get the question, how come the joint didn't mirror over either? And it has to do with like, what is the reference? Well, over here, the reference is that particular edge. Well, that edge, you can see it over here, but it's not the same edge. It's a totally different edge. And so that's why the joints don't mirror over also. But here's a cool trick. It's in the correct location. So instead of creating a joint, I'm going to do an as-built joint. So I'll say as-built joint, and you'll notice the dialog is really simple. I like to tell it, okay, we're going to do a Revolute joint. It says, what are the components? I'm going to say, well, I want the leg to rotate around something that has to do with this plate here. And now it says, what is the snap or what is the joint origin or whatever? Well, I want it to revolve around, I could pick the hole, you know, I could turn things on off if I wanted to, or I could just say it's going to revolve around a circular edge like that. I'll say OK, and we've now built that joint. And I didn't have to, you know, click on one edge, click on another edge, and position them into place. Because they were in the correct location, they all I had to do was the as-built joint. In fact, the as-built joint is one of my more favorite commands inside of Fusion. So I looked over, Angelo's been helping me out with the chat, and it looks like he threw a question in here. He said, will you be showing interference in the inspect menu? That's an excellent question. I've shown this, I did this a lot in the pencil sharpener assembly that I did with a live stream. And basically what we're doing here is you can see interference. And I have an idea why they're asking this is because of this bolt has a square head on it and it's going through a round hole. I have a feeling that's why the question came up. So it says, you know, what do I want to select? Do I want to include coincident faces, etc.? Well, I'm just going to draw a selection box maybe around these parts here, and I'll say compute. And it will show me visually, sure enough, what is clashing. And we can see actually there's a couple situations and stuff like that that seem to be highlighted and stuff like that. So And I do that. In fact, with threads, you can pretty much ignore because it's really tough to get like, I could rotate the nut so it's actually binding with the threads the correct way and all that kind of stuff. But this is exactly what I think why people are asking the question is, I have a round hole and we're putting a larger square head through that. You guys are kind of thinking ahead. I think you know me now. This is, I'll be honest, this is how I design. I'm like, okay, I'm assembling this thing together. It's looking great. I will run a clash analysis or an interference analysis after a while and see what's clashing. I'm like, oh, I'm going to have to change the size of this hole. Well, I created this hole 3 weeks ago. Where is it in the timeline? How am I going to do that? And this is, you're going to see this in an upcoming live stream. We're going to fix some of these errors. And I did the exact same thing in that pencil sharpener assembly. We got pretty much to the end and we realized there was some clashing going on. How do we fix that? So I think you guys are catching on to my methodologies here. But that's a great question, whoever asked that. I appreciate that. So yes, I do the interference checks every so often. So we're going to pretend that we don't know that there is an issue there, even though now we do. So, okay. What I want to do now is simulate how this thing is actually going to fold up. So these legs in the real world, you push this pin in, it's got a little spring in there, right? And it's held, it's kind of hard to rotate. It's held with the washer and the clip and stuff, and you push this little pin in and it allows you to rotate the leg. But obviously we need something over here for it to clip into, and I also want to make sure I'm rotating the leg the correct angle and stuff. So what we're going to do now is a cool little trick. I'm going to come in here and say assemble drive joints. So I'm going to drive that last Revolute joint. Oh, sorry. Yep. Let me turn on my joint type real quick. We go object visibility, joints. Okay, let's do it this way. I'll say drive joint. I can click on that guy there, and I'm going to rotate it in this direction 90 degrees. But notice where that puts the leg. And sure enough, we can see that it rotated at 90 degrees. Well, I want it to be horizontal. Well, remember we captured that angle into our clipboard? So I can come in here and say, I'm going to say plus, and I'm going to paste in that angle. And notice it remembered that 10 degrees, 10.305. Well, obviously plus was the wrong one, so I'm going to say minus. And so it is now rotating 90 degrees and another 10 degrees. And we can see that that's perfectly horizontal. I'm really emphasizing this because sadly, we see a lot of times people are like, okay, I'm going to just rotate this until it looks horizontal right there. Well, that's pretty close, Okay, maybe let's just go minus 99. Nope, that's too little, 99.5, whatever. Let's not guess. Let's use the actual math from the software. So 90 degrees minus 10.305. I would never have figured that out, right? But Fusion did. So I'm going to go ahead and say OK. And we now have that leg in the correct location. Okay, so we now know this is where the pin is going to be. Let me turn my object visibility back off real quick. We now know that's where the pin is going to be when this leg is perfectly horizontal. I'm going to go ahead and capture the position of that leg. Okay. And I'm going to modify this sheet metal part. So one of the things I like to do is I like to click on the sheet metal part. It highlights where it is. Okay. And it's this leg support plate. So I'm going to go ahead and activate that. And notice my timeline becomes very, very simple. And these were all the steps that were required to create the leg support plate. So I'm going to build a sketch. Let's click on this face. I'll create a sketch. I'm going to project the important geometry. So I obviously want to project this pin. I'll say OK. We now know where that is on the sketch. And I want to create kind of like a curved slot because this thing's revolving around. In fact, I'm going to go ahead and project that guy also just to have it. So let's create a circle. And I'm going to do a construction circle from here to here. Okay. Now I want it to go through the top here. I think. Yeah, I think I do. Yeah. Let's do that. So this is where the pin is going to rotate from. Then I can use a slot command. And you'll notice we have regular slots, but then we also have these arc slots. So I'm going to do a center point arc slot. The first thing it says, select the center point of the arc. So I'm going to start over here. And then it says the start point of the arc. So I'm going to click up here. And then you can see it's basically following this construction circle. And I'm going to click there. And now as I start to move, we can see there's that slot. Now I'm going to turn off the construction. And I realized I probably should have put the circle through the center of, in fact, let me back up because I screwed up. I want to capture the center of that circle for the larger circle. So let me do that again. Construction there. So I'm going to come down here to there. Well, why is it not catching to the center of that circle? Give me a second here, guys. Let me project. Instead of projecting the pin, I'm going to, let's turn off that pin. Let's see what is going on. Let me see if I can project that circle instead. So let me project maybe that guy. Nope, I didn't. Oh yeah, I guess it did. Okay. So let me see if, does that catch to the center? Huh. That is odd. I thought it would project a center point for me, but it's not. So I can kind of get around that using center lines here. So for example, I can draw a line like so, and a line like this that would go across, right? So it's catching those quadrants. So now I have a point that I can get to. So now I should be able to do my circle. So I'll go from there to that point there. And you can now see with the little tiny bit of error that I was going off of that point when I should have been going off of this point for my arc. So let's do the slot again. I'm going to turn off my construction. It's asking for my center point first. Then it's asking for a start point. I'm going to zoom up and make sure I grab that arc there, or that point I should say, and that point there. And now we should see basically equal spacing, which we can definitely see right there. I'm going to give this a little bit of a larger slot. So I want it to be 13 total. I'll say OK. And the reason for the 13, if I turn on the pin, you can kind of see the size of the head. I just wanted to make sure there was enough clearance between the pin and the side there. So I now have this. And it's kind of hard to tell, but it's a curved slot, and it's in the exact location that I need it to be in. Let's go ahead and extrude this guy. I like to start to drag. Well, I want to go a very specific distance. So instead of distance, I'm going to say go to this face, and you're going to see that it's going to extrude the correct distance to whatever the thickness of that face was. So instead of me guessing, I said go exactly to that wall right there. Now, if I zoom up, it might be kind of hard to see. We're running into an issue here. I've got multiple objects displayed. I'm telling it to cut into there. Watch what happens when I expand open objects to cut. It's actually cutting the leg support, and it's cutting through the lock pin. And I could visually kind of see that right there. But I'm going to turn off lock pin, and now you'll notice it's kind of filled in. It's no longer cutting through that. The only thing it's cutting through is the leg support plate. So this is a really cool thing, which unfortunately it's usually folded down, so kind of hard to see. So if I were to expand that open, I can visually see, and this is pretty cool. I mean, think of, like, for example, maybe you're doing some kind of pump housing and you want to go through, 3 or 4 different things, like the front plate, a gasket, a middle plate, a gasket, a back plate, etc. You could have it cut through all of those all at once with one profile. So kind of a cool little thing there. So definitely make sure you check that out. I'm going to only cut through the leg support plate, and I now have done that. Okay, I want to put this over on the other side for the other wing, or whatever you want to call these little flanges and stuff like that. So let's go ahead and mirror. So I'm going to say mirror. Now instead of components, I'm going to change to features. I could do faces, but I hardly ever use that because I'd have to manually pick all of those faces, and there's things in the way, and it would just take time. Whereas I could come in here and say features, mirror that extrude feature right there. Bonk. I could mirror multiple features. If there was a chamfer on it, I could do the extrude and the chamfer. So it's just really powerful. What's my mirror plane? I'll grab that construction plane, like so. Okay. Did I do it? Oh, mirror plane. Click it. I was like, what's going on here? Here's my kind of my preview. I'll go ahead and say okay, and we now have that slot over here on the other side for this leg, and sure enough, you'll see that the pin lines up perfectly with that. So pretty cool methodology of using existing geometry. And I don't know if you remember, this was a couple live streams ago, in the drawing I had where that slot was, but I said we're not going to create that slot, we're going to use geometry to help with that. And this is that actual step. So okay, here's another cool little trick. I'm going to expand open my joint right here. Hopefully I can see it. Let me activate my table assembly. Okay, so there's that joint there. I'm going to go ahead and edit this joint so you can see where it's at there. I'll go ahead and say okay. I can also edit my joint limits, and I can turn on rest, and I can tell it to rest at, like, well, actually let me do it on this other one. It'll be, since that one's already been created. Let's just do this guy. So I'm going to come in here and say edit joint limits, and what this will allow me to do is I can specify the maximum that it can rotate. Let's just say is 100 degrees or whatever, and let's go maybe 105 or something a little bit different. So that's the maximum that it can go. And again, I would probably use maybe a contact set to figure that out, but I'm just kind of showing a quick example here. So let's say that's the maximum. There's this rest command, which is really kind of cool. That's set to 0. And the minimum is set to 0. So watch what happens by turning this rest on. I'm going to drag this to the right, and you'll notice I cannot go any further than 105. But as soon as I let go, it snaps back to that rest position. So it's kind of a neat little trick to get it to always go back to the same location. In fact, you'll notice it doesn't even show that it's changed position or anything like that. Okay. Let's edit this joint here. Or I'm sorry, maybe I need to edit my joint limits. Maybe. Okay. Oh, I'm sorry. I'm doing the wrong command. I want to do drive joints. Let's go drive joints. That guy. It's set to minus 100. Let's set it back to 0. I'll say OK. Capture that position. So I just wanted to return that back to its original location. And then what I'm going to do is let's show all of our components like that. And we are going to mirror these two legs. Now if I come over here, drag this down a little bit, you'll see that we have one leg assembly, and I'm going to change the components. We have one leg assembly, we have the second leg assembly. What's my mirror plane? Well, let me see. Do I have that? Oh, I've got these planes here, so let's turn it. Well, I can't mirror that one. That one's not correct. That one's not correct. So none of these planes actually help me right now. So I need to create, I'm going to do a mid plane. And I know it needs to be exactly between like this flat face and this flat face right here. And you can see that it created a plane that cuts right through the center of that. So let's do our mirror now. Components, leg, leg. That guy there. Looks like they're in the correct location. I'll say OK. And you can really see why I love the grouping, right? This is a rigid group. Everything moved together. You can even see the axes that we used. And just like before, these are all individual. If I drag that out, they're not grouped together, but just like this, I can say rigid group. I'm happy with that. Rigid group, happy with that. Now I just need to create the as-built joint. So I'll just come in here and say as-built joint, that. I want to do a revolute around like maybe that bolt right there. I'll say OK. And we now have, oops, I need to ground ground that guy too. So let's pick on him. That is part of the end cap assembly 2. Let's ground that guy. Now if I grab that leg, we can sure enough test to see how that would rotate into location. Pretty cool. And then the same thing, I'll just do real quick. As-built joint, that guy, revolute around like a circular edge or a circular face, and we now have that guy that rotates. Okay. So pretty quickly we started with one leg, positioned it where I needed to be, used that position to help us create this little slot. We mirrored that slot over, and then we just ended up mirroring the legs. We only had to do one leg, and now they're all in the correct location. So the next thing that we're going to do is the handle. And there's actually a handle that comes off here that you kind of lift up this whole thing with and move it around. So let's go ahead and do that real quick. So I'm going to fold some of this stuff back up just to simplify my design. Okay. I could create, you can see all the, basically the copies or the mirrors of my leg assembly. I could create something called, all my legs assembly or something like that and put those in there. We're not going to worry about that right now. What I want to do is work on a handle. So I'm going to right click on table assembly and do a new component. We'll call this handle. You'll see everything kind of ghosts out a little bit. And then I want to use the information. We created these holes when we created the sheet metal part, so I want to use that information. So I'm going to click on that face and say create a sketch. And I'm going to project, let's go ahead and project that whole face. That way it gives me the location of those circles. Okay, here's where we're going to do a new command that we haven't really done in any of my live streams before, really, is this 3D sketch. So I'm going to turn on 3D sketch. And you're going to see something interesting. When I click on this line command, you'll see this dialogue, these planes and rotate lines and all this kind of stuff. And so if you're ever creating a sketch and you see this thing and you're like, whoa, what's going on? It's probably because you accidentally somehow turned on 3D sketch and you'd want to turn that off. But we want it on because we're basically going to draw how we want this handle to look coming off of this part right here. So 3D sketch is turned on. I'm in my line command. I could do the spline, but in this case we're going to do line. And it's going to catch that point. So watch what happens when I click there. This little triad jumps to that point and it's allowing me to draw a line. Now you'll notice that one of these planes is highlighted blue. So that is my YZ plane. So you can kind of see that right here. Here's the Y. There's the Z going up. So it's basically saying it would draw kind of in the same plane as this large face. Well, I want to draw out away from the part. So I'm going to click on this plane here. And now you can see we're kind of doing the XZ plane or whatever. So we're kind of coming out this direction. So I'm just going to randomly click some distance straight out. And if we kind of rotate, you can kind of see, sure enough, in 3D, we're drawing a line out. Then I want to kind of come down at some angle, something, I'm not sure yet. Okay, now we're still on that plane. Now I want to start drawing in that direction. Well, I can't do that with this plane, but I could do it on this plane, or I could do it on this plane. It really doesn't matter. Let's go ahead and maybe do that plane there. And now you'll notice we're kind of drawing in that direction. So see how it's starting to look, it's kind of hard to see, but starting to look like we're drawing in 3D. Then I need to kind of go back up again. So let's just go up like so. And again, I'm purposely making mistakes here to fix things. And then the last thing I want to do is close out at this point right here that we projected. It's kind of hard to see, but there's a little circle there, so I'm going to click on that guy. And we can see our 3D spline, our 3D sketch using the line command. Now I'm done, so I'm going to hit this green checkbox. Okay. Now you can kind of see why that could get kind of confusing if that was turned on by default. So typically when you're drawing normal sketches, you would not have that on. So what we want to do now, obviously, is kind of control this sketch. So we're going to use some constraints. So the first thing I want to do is I want this line and this line to be equal. So I'll say, like, for example, that line and that line I want to be equal. I also want them to maybe be parallel with each other. So I'll say that line and that line have to be parallel with each other. And you can see how that's starting to fix things up. Okay. I want, let me do, I'm going to undo real quick. See if I'm on the same. Yeah, I'm going to do these dimensions first. So I'm going to throw some dimensions on here. So I'm going to say I want this line to be, just looking at my dimensions here, 85. So we can see that that line grew. I'm going to create an angle here. I want that to be 135. So we can kind of see how that changed. And then I'm going to throw a distance here. I want that to be 120. Oops. And I'll hit enter. Okay, so what I'm doing here is basically defining what I want that to look like. I'm not sure why this point is moving. That is kind of odd. Let's see if we can fix that. Of course, when you do it live, it doesn't work the way you expect it to. Let's do collinear. That line and that line. Nope. Okay. I'll do equal and parallel. Okay, that looks good. Oh, I know why. Duh. I want to do perpendicular, like so. There we go. So you can kind of see how I'm using constraints, and I basically said that has to be 90 degrees. I could do the same thing here, make sure that that's perpendicular, and now we can see that sure enough my sketch is fully constrained in 3D. Then the last thing I'm going to do is I'm going to use the pipe command to create this handle. So I'm going to come in and fillet these corners. So let's just go maybe at that point right there, and I want it to be 25. A little hard to see, but as I continue around, it's going to fillet these corners for me. Now here's something that I find a little bit frustrating. You saw that it was fully constrained, but by putting these fillets on here, it kind of turned them back to be blue. But if I try and move any of these lines or these radiuses or anything like that, nothing moves. So I'm not 100% sure why it's no longer fully constrained, but I can't move any of these. So I basically tell myself, if it was fully constrained, it's going to be fully constrained. And just by adding the fillets, it shouldn't change anything. So I'm going to say this is okay. I'll say finish my sketch, and I now have this path that we are going to use to create our handle. So let's do, I'm making sure handle is active. I'm going to use the pipe command, and you'll see why here in just a second. What is the path? Well, because it's filleted, it's going to sweep all the way along. So that's my whole path. You can see instantly the preview. What is the section size? Well, I want it to be 25 for the section size, and I want it to be hollow. So I'm going to activate that little hollow command, and my section thickness is the wall thickness, right? So I'm going to say 1.5, and if we rotate, you can kind of see what that looks like there. Real fast command, the pipe command. Instead of drawing a profile and using the sweep command and all that kind of stuff, and then having to shell it out or whatever, it's all one command. Okay, so we now have basically this little handle here, but it's just floating in space. There's nothing to connect it to this plate. I see we're at near the top of the hour. We're gonna go a few minutes over. We're getting pretty close here. We should be good. So I'm gonna activate the leg support plate. So that's this guy here. I'll activate him. And let's turn off the handle for now. We don't need him for now. I want to create some pieces of metal that are actually welded through these holes on the actual miter saw stand behind me. I don't know if you guys have noticed that, but it doesn't really show up in the camera, but there's the miter saw stand that I've been taking all these measurements off of. Okay. So I'm going to create a new component under the leg support. And I'm going to call this handle mount or something like that. Something that's easy to figure out. And so you can see that that's actually being created, apologize, being created underneath this leg support plate. So, okay. Then I'm going to turn on this existing sketch. Now we use this sketch to create this hole, so I'm just going ahead and turning that back on, and we're going to use that profile to extrude. I love this new command. You see me use it almost every single time, this thin extrude. Basically, we're going to create a small insert here. So check this out. I want it to go a certain distance one way and a certain distance the other way. So I'm going to say 2 sides. And in the first distance, I want it to go 20 millimeters. And it gives me a nice preview of what that's going to look like. And in the second distance, I want it to go a different distance. Let's just say 8 in this case. So we can see that it's going 20 millimeters that way and 8 millimeters that way. That's what 2 sides does for you. One side is usually what we use. 2 sides allows you to go 2 different distances, and then symmetric is the same distance both directions. So this is pretty handy in this example. Wall thickness, we want to be 1.5 for both of them, not 11. We want it to be 1.5. And wall thickness 1.5. And just like that, I created this little insert. It's right where it needs to be. And in reality, it gets welded into place. So again, didn't have to create it somewhere else, figuring out dimensions. I was able to design it what I would call in context, in the correct location. Okay, so let's turn the handle back on. And I'm actually going to activate the handle component. And what we're going to do is we're going to somehow assemble this whole thing together. So I'm going to create a hole that goes through, and then we're going to bolt this thing together, and we'll call it good. So I'm going to use the hole command, and I'm just going to click on this face somewhere like so. And I showed this in my previous live stream. When you click on a circular or cylindrical edge like this, or face I should say, it finds the correct tangency and basically puts it at 0 right along here. Now I'm going to reference this flat edge right here, this flat face, and you can see it gives me a distance. Well, I want that hole to be 10 millimeters from that edge, and then I need the hole to be the correct size. So in this case, I want it to be a 6.5. And now we can kind of see the preview better. It's 10 millimeters from this face right here. It's a 6.5 diameter hole. And again, I want it to go through all. So we can kind of see that going through the handle. But if I expand open objects to cut, it's cutting through the handle and the handle mount at the same time. And that is what I want this time. I want to make sure we're basically drilling through both of these at the exact same time. So I'll say OK, and there we go. We've drilled through the handle and the mount. Even though the handle was the active component, we were able to drill through both of them. So I'm going to do the exact same thing over here real quick. I could use the mirror command, but I'm just going to click on that face. We'll reference that face there. We know it needs to be 10. It remembered the 6.5. Now if I expand this open, we only see handle. Why is that? Well, we only created the mount over here. There isn't a mount over here, so the only thing it can cut through is just the handle. But that's okay. You're going to see why here in just a second. But there it is. We cut through there. If I turn off the handle, sure enough, we only see the mount on one side. Okay, let's go ahead and assemble this together. We'll create a Mcmaster car component. Just to speed things up, I'm going to search by the number 92000 alpha 439. And it didn't find anything. I must have typed too many zeros, which I did. There we go. This is a 18 by 8 stainless steel hand Phillips head screw, a metric 6. So let's do that guy. Download. It's going to bring it into our session here as it's thinking. Not sure why it's thinking. I don't see any questions. Hopefully it's doing an autosave. If you have any questions, I know we're kind of right at the top of the hour. If you have any questions, now is the time to throw them in there. Hopefully Angela's probably been answering all of them for me, so I appreciate that. I like to rotate this kind of closer to where it needs to be, so I'm going to rotate it 180 degrees, and I might move it kind of down like so. Again, doesn't have to be perfect. I'm just kind of getting it in the general location. Then I will create a joint. Again, you can kind of see that 3D glyph really is a little bit more visible to see what direction things are pointing. So it's kind of a new enhancement we just added. So I'm going to go to this, instead of the edge, I'm going to go to this face, and it's going to capture that outside face. And we can see that sure enough, that screw is going to go perfectly where it needs to go. I'll do that one more time. We'll bring in the nut for it, which in this case is 94645 alpha 205, looks like. Yep. I sure love this Mcmaster car implementation. It's so handy. Instead of me having to model or search like GrabCAD or whatever, I can just bring it right from Mcmaster car. This time I'm not going to rotate it just to show you don't have to. I'll just go ahead and say that's where I want it. Create a joint. Grab that center mark there. And I'm going to zoom up and grab this edge here because that's where the hole is. And you can see, sure enough, it has a top, a middle, and a bottom. So I'm going to click there. Now, it brought the nut, but it put it in the wrong orientation. Well, I can just click this little flip icon, and we can now see that sure enough, it flips the orientation, and it is in the correct location. And we've just bolted that where it needs to be. Okay, so let's activate, making sure I'm doing this correctly. Okay, so I'm going to activate this leg support plate like so. And I'm going to basically copy some of this stuff over is what I want to do here. So I want to copy this little insert, this handle mount. And then I also want to do the screw and the nut. Okay, so where is the screw and the nut? Well, I can manually try and click on it here, and you'll see that nothing is happening. In fact, let me kind of zoom up here. But if I click and hold for about a second, you'll see all of these vertex, edge, etc. But if I go to parents, I can actually see right here, it's under the handle. So you it starts at the most basic level, the vertex, and then the body, and then the component, and then the sub-assembly, etc., all the way to the very top level. So that's what this parents is. So you can almost think of this, as, grandparents, great-great-grandparents, etc. So I can grab it right from there. Isn't that cool? So I'll do the same thing with this nut. I'll click on the parent. I'll grab that guy there. And then same thing with this guy here. That is... I don't want the handle. I don't want the pipe. Okay, so let me do that with the handle mount. So I'll grab those guys. I'm going to right mouse click, and I'm going to say move copy. Now, how far over do I need to go? I have no idea. But there's a really cool command here called point to point. Notice we're copying components. I'm going to say point to point. Now the important thing is, before I start clicking my points, I want to make sure that I'm creating a copy. Otherwise it's just going to move the parts. But by saying create copy, it's going to copy the parts for me. So what's the origin point? Now I can click this guy here, and if I hover over this face, you can see it's a little hard. There's a little plus symbol right there. It found the center of that circle, so that's my origin point. What's my target point? Well, now you can see there's a target over here. I'll click that point there. Let me make sure I'm grabbing that. Target point. And you can see that it's creating a copy of those guys for me. And then you can kind of see why I didn't, I did the handle over here, but I didn't worry about the insert or anything like that, because I wanted to copy the screw and the, the bolt and the nut all at the same time. Okay. So here's my handle. But then you can see there's the screws and the nuts and the inserts are all part of that leg support plate. Let's go ahead and activate this handle real quick. Now I do notice actually that the screw and the nut are part of the handle, but not on this one over here. So maybe I want that to be part of my handle. So I'm going to expand this guy open, grab those two guys, and drag them into my handle assembly. Now if I turn off my handle assembly, these little sheet metal mounts, or these metal mounts, are going to be welded to this sheet metal plate, so that's great that they're part of this leg support plate. But then the handle is all of the, for example, the screws, nuts, bolts, washers, and then the actual handle itself, which is right here. So that's kind of the whole organizational thing. Like, again, I mentioned this earlier, I'll kind of design the parts, I'll design them in context, I'll get a couple on the screen, and then I might reorganize where do they need to go. I want my hardware to be in a hardware subassembly, or I want the handle and the nuts and the bolts to be in the handle assembly and not part of the sheet metal assembly, etc. So, it's good to have a good idea of what you want your assembly structure to be like, but you're not nailed down to it, which is so cool with Fusion. We give you that flexibility. Okay, last thing I'm going to do here is A for appearance. I'm going to drag this plastic bumpy texture onto that handle because it's kind of a rubber coated handle, and we are done. Okay, so I would go ahead and save. Now you'll notice I have this little warning message because I've been doing multiple versions of this and there's newer versions of it, but this is basically the end of this design. So hopefully you learned some new things. The 3D sketch can take a little bit to get used to. Go ahead and do simple things like, it'd be great for like routing wires, for example, or like ducting in a ceiling or something like that. Click on that 3D sketch option and it'll give you that triad, and then you can pick which planes you want to sketch on. You can type in distances, you can use constraints, you can use dimensions. It's really, really powerful. But then make sure you turn it off when you're done with it. That way, when you're just trying to draw a rectangle or a circle or whatever, it doesn't get confusing for you. I'm going to check the questions. Yep, somebody posted a question about the yellow out-of-date icon. Yeah. So let me show you what that means. So it says, click to get the latest version of this design. We're actually working on version 20 right now, but I've been doing other, I've been moving forward and doing other parts of the whole assembly, like the wheel and all that kind of stuff. So you can see right here, I actually typed in when I finished our live stream in session 3, when I saved it, I tagged it as that, so that way I could figure out, oops, I need to share my screen. Sorry. You can see right here, in this design, I'm working on version 20, but I've actually got 25 versions, basically, of this thing. So, okay, yeah, Angelo, thanks. Share your screen. So that is why you see this little out of version warning, because there's newer versions here. Okay, And that's how I do these designs. I mean, I wish I had the time to design the whole thing and then do a live, bunch of live streams, but I'm almost kind of like doing this with you guys. So I'll design a couple parts, we'll do a live stream. I'll design a couple more parts, we'll do a live stream. With that said, make sure you attend next week. Angelo will be presenting on his CAM series. I think he's going to take that weird part that we've talked about previously, and he did some tool paths on it, like how would you machine this with a 3-axis machine. I think what he's going to do next is the one and done. There were quite a few questions about how to do this with like a 5-axis machine, so I think he's going to show how he would mount that and use a 5-axis machine and tool path that in like one process. So fingers crossed I said that correctly. And make sure you tune in next week. The week after is spring break, and I will not be around. I'll be traveling, so there will not be a live stream session 2 weeks from now. So make sure you tune in next week, and then there'll be a short break, and then we'll continue on. So with that, I want to thank everybody for attending, and have fun fusioning.